power. So like that, you start looking into it and then come to the configuration of the product gradually. So this type of questions can be asked because we are not going to design, but mostly questioning as to how this function can be satisfied by a certain set of activities which are planned out very well. He gave an example of how to allow the students to get into the bus. The options may be there. You can put there are slopes can be given. You can have steps. You can have sinking steps. There are a number of things are available. So they can give the options of that type. Question on design function and means by giving a need gap. That's right. I mean, you just the question is like this. I need a simple way to move heavy furniture at home from one location to another without additional help. This is, every time it happens, there's a big almirah. I want to move it and no one is there. I want to move it from one to other. How will I do it? Then they will think, what are the means? They may say that you can put some lever and put it. Then you're spoiling the floor. So there are negative aspects of it. He should look into all the possibilities and find out the best way of doing it. Primary and secondary functions are considered in the design. A table fan. What is the primary function of a table fan? I mean, you give an example. What are the primary and secondary functions to be considered in the design of a fan? Primary function is to rotate the blades. What are the secondary functions you want? Swing, adjustment, height adjustment. These are all secondary functions which are required to comfort. So thereby you should know what all other possibilities can be brought into the design which can be embodied in the design in course of time. We are not asking him to do now, but only identify those components which are to be integrated with the design so that the design is a acceptable one. Question on design constraints. All designs cannot be very well, there will be a lot of constraints in limitations. Design of a ladder for home use. What will be the constraint? Size is because at home you can't keep huge ladders, but at the same time you want that one. So there should be some means by which it can be folded or whatever might be. Second, lightweight. It should be able to do. So like that, a few points can be brought in which will allow the design of a ladder to be achieved. That's all what we are asking. These are short questions. 5 minutes it will be over. Okay? I hope that you will be able to formulate such questions. And none of us will be putting the questions. Your questions will be taken and then the right ones will be put together. So you have to think about the questions because it's a very difficult, even for me it was difficult to find out good questions. So please think about that one, look at internet sometimes, look at good designs, plan it out, look at the environment, what's happening there, and then take up designs which are simple enough and questions can be formulated based on that one. See, another one will be identification of X in the design for X in a product example. You have seen number of X's are there. Design for what? 1X. Design for safety, reliability, quality, manufacture, logistics. Quite a lot of things are there. Anything which is not connected with design is X. So thereby there are a number of things. And you give an example, what are the X's considered here? It has considered X for this one. Design has been looked in from that angle. Design has been looked in from this angle. Design has been looked in from this angle. That's all what is required. In other words, he looks at the design, evaluates it from these angles and says that it has fulfilled these angles clearly. Then another question can be on comparing the design for its merits and demerits. All the designs are not best designs. There may be one good design, the other one may be slightly less. People will decide depending upon what they want. That's different. But from a design angle, one design may be very good one. The other one may not meet all the requirements, but cost effectively it's good. So you can see that every design need not be the best design. There are designs with limitations. Some of them prefer that one. Some of them may not prefer. So for example, if you take a soap box, simple soap box, there may be design where there is no hole at all. the water will get in there, the soap will go off without your taking bath. So thereby what happens is that you have additional holes there so that it will drain off. Even if there after some time it will get blocked, and again the same story starts. So the design is not a very good one as far as that one is concerned. So people are putting two of them together, one with a hole, the other one collecting the water, so that after some time you can drain off that one which doesn't close the door totally, the holes totally. There are other designs also available. There is a sponge which is there so that you can keep it over there. The sponge will absorb the water and thereby the soap is always dry. So there are a number of options available. So simple designs of that one will give an option for the student to think about the merits and demerits of that one. So take any casual product and then say what are the merits and demerits of this one. Simple questions on product geometries. Symmetry is a thing which you can see in many products. You take a chair, it's symmetric. You take anything else, building also is mostly symmetric because it's attractive. Human being itself is symmetric. Only thing is it's not perfectly symmetric, but there are features which are quite symmetric. So symmetry is one thing which is always seen in the non-symmetry is not appreciated that much. But then you can bring in the non-symmetry in an appreciable fashion if you are clever enough. So often you can see symmetry is normally the case. You can see any product, there are symmetric products which has got a lot. If you take anything, of course this is the addition, something, whatever might they say, this one is a symmetric product, but other things are detailed. So symmetry is a common thing in many of the products. So one way of looking at a product is to make it symmetric as much as possible, because aesthetically, cost-wise, everything is cheaper. But there are products where symmetry may not be attractive to a certain extent. You look into your design of your clothes, everything is, certain symmetry is allowed, but not full symmetry sometimes, and thereby a deviation from that one also will be accepted in certain fields of activity. Say tiles, the paving tiles, geometries are there. You can give a simple example of one tile and give a mistake on that one and see, correct the mistake so that it will be a paving tile. It's clear that it has got also symmetry which is not seen directly, but when you put it there, you see the symmetry. But say for example, interesting, even now I don't know what exactly it can be. Say if you put a square or a triangle, they can be matched very well. You can put a square, two triangles, that's all right. Square and square will match very well without. And if you put a pentagon, it will also match. Hexagon also will match. But when you go on like this circle, it doesn't match. Circle means there will be gaps coming. Why that gaps coming? That's a good interesting question to be answered. Because the angles are the ones which are allowing that gap to come gradually. They are not symmetrical angles. The other one has to match with the other angle, and that will not match in the case of a circle. So thereby, if you put three circles, there will be a gap there. Whereas if you put a pentagon or a hexagon, there won't be any gap coming there. So like that, a simple questions of that type can be asked so that he will think. The answer need not be correct or not. We are not looking into it. Please don't think that the obvious answer should come there. But whether he has thought of it and then given the answer. Identification of value addition products. That some of the things are very, very thing. I may say, I take my pen drive. Is it possible for me to see how much free space is available without putting it in this one? No chance. But that's a value addition, Every time you try to put it, you don't know, now I have to take the other one and put it there. You see, these are some of the things which are very, because I'm not an electronics engineer to find out what's the solution for that, but I'm just giving a clue. Another thing which I always observed in the design of a pen drive is the fact that every time you put it two times. Because there's no way of detecting which is it all depends on the computer. The motherboard, how it is coming, and thereby one side is the board is there, one side it gets in the board, and the contacts are flat contacts, that's why it's coming less. But every time, you do it live, and then most of the time you know that there will be some marking where you can put it. But if you can have a feel of that one, it will be a good design to be worked out. So value addition can be thought of in different ways. Why a specific product is designed so? Why can't, I mean, say, over the years it not has changed, it has been always like this. Why? There should be some secret behind that. Look into that. I mean, I'm not giving an example here. Give a thing which has remained for a long time, sustainable design, it's called. It goes on without much of a major changes. Why that is there? So you will see that there are a number of things which are remaining, say watch design for example. You are not changing any of the things other than the dial. I mean, inside there may be, but appearance wise, we are not changing much other than the dials, and appearance only is changing. But the needles and other things, why can't you have a needle which is a larger one for the hour and the smaller one for the other one? I mean, there is nothing wrong in it. You are used to it. So why that design has come like this? And you never thought, why can't I have this thing, a longer one for the second, then minutes, and then why can't I reverse it? That also is a possible design variation which is not existing at all. So there should be some reasoning for that one which is to come in there. Ask for some clever but simple design. I'll give an example for that one later. Clever means you have to think about it. Yeah, it is there, it was there, but I didn't know. That side of it, it is already, if I get the clue, it's over. So that type of questions are to be asked. That clue is the one which you can indirectly give it, but then you have to plan it in such a way that a clue is not directly given but indirectly given, so that he thinks about, oh, this is required, so it should be like that. That way have a problem to be explained. Now sketch. I given two. Sketch a short 5 centimeter length screwdriver. Everyone would have seen a screwdriver. Sketch a long 15 centimeter length. These are the two questions. I mean, he will draw the same one with two and the other one with a long one. But you can see the difference. A short one will have a larger handle because it's very difficult to hold, so you do like that. And the longer one will have a long handle and serrations. The short one need not have serration because it's large. Of course, you can give it also, but normally wooden ones and other things are available with that. So observation is very important. If you have observed that one, otherwise he will write the same thing with a small one here also and the other one with a long. But that's not the right design for a short this thing. There are short ones also available. I'm not saying that it's not, but generally when you have got a short this thing, to get the real tightening torque, you require a larger diameter there. Whereas the other one, you can hold it out very well, long length, you can do it. But if you are this much and then a long one, that's not a convenient one because there is a short and then storage will be much more, which is not required for that screwdriver. Sketch a 3-pin socket and plug. You wouldn't have looked into that the third pin is thicker and longer than the other two. That's the observation part. He will write 3 pins, that's all equal. That's the normal way everyone will just say. So ask him for, and then a chisel for example. A chisel, you will have a handle, then there will be a cap for that one, and then only the thing is put there, and then the angle, everything is coming. So he should be able to sketch it reasonably well to know that it's a chisel. I mean, some simple examples like this. Sketching only is the requirement. The idea of sketching is to have observation. Whether he has observed the product carefully, because you train them to do that one. I'm not saying that suddenly you give a problem. You tell them, when you look into it, look at the peculiarities of that design. Why it has been done like this. And then it will be easier for them to understand simple things to be drawn and then explained. This is a little longer question. A steel tube of about 4.5 meters is available for making the frame of a chair. This tube is allowed to be bent in any direction at 8 places only. That's a clue. Okay, 8 places. Otherwise, no, cutting of the tube and joining the parts is not permitted. However, any extra length may be cut if you want. If he doesn't want for 4.5, you can make it out of 4.2. Once the frame is ready, the seat, which is a square plate of 45 centimeter, is to be screwed, and another rectangular piece of 45 centimeter length and 15 centimeter width is to be screwed as the backrest. He gets a clue. 45 is the width. Both are 45. That means the width of this one is 45. So, see, this is how the clue is embedded in it. He should be able to understand this one as an engineer, that the seat is 45, the backrest is 45, so there is a 45 connection somewhere. And if you look in 45 into 8, how much it comes? I mean 8 into 45 will be? Yeah. But 8 is only bent. 8 is only bent. Yeah. So what happens is that he has to find out the bends are there. If you have a one bend, there will be 2 pieces on the other side, isn't it? One bend means there are 2 pieces. Every bend will have 2, and then subsequent bend will have only one of them each. So in the initial one, 1, 2, like that, if you bend it 8 times, 1, 2, 3, 4, like that it will come there. So you can see how many segments will be coming in the system. Now he has to plan how to conceive this thing, and of course everyone has seen this. So the plate is there, the other one is there, the bending is there. So this is a known thing, but at the same time the question is such that it's not available directly. If it's seen, okay, that's over. So like that, questions can be little longer time where he has to think and then write it out. Design comparisons. We have got 3. The first one is a fan of the old type. The second is a little modern one. The third one is a further one. You can see the differences there. Cost-wise, safety-wise, appearance-wise, there are a number of things which are likely to be there. The last one is very appealing. The first one has got a slider for controlling the thing, which is very, very crude, isn't it? And first one doesn't have safety. The cover is not full, so thereby safety is at a risk. The second one is having, but still it has got a slider. The third one has got buttons. So you see how things are, so you can evaluate comparison. One is that, the first one, evolving design, starting one, simple one, but has got limitations of this type. Second one is the improved one, has got this ones and limitations of this one. Third one has got this one. Like that comparison, that's the idea, is that the product is analyzed by the student from various angles. Safety angle, elegance and appearance, then ease of operation, reliability. The reliability is much better for the last one, because each one, if one doesn't press, at least the other one will press and get in, because this one slider, if goes off, it will not be able to function. So that way there will be certain advantages for each of them. One question can be on problem definition. How you define the problem? Need is the one which is given there. But then from the need you have to define the problem which allows us to have the final design to be there. The need of the user is, I need to use electricity for different applications in the lawn of my house. That's the need. Write down the questions to be posed and arrive at the right definition of the problem. What are the questions you are going to pose to the user? And depending upon the answer, how are you going to confine your design definition? That is, gradually you have to come down to perfect design specification or design definition. What will be the question? How far is your lawn from the nearest plug point? That will be the first one. If it's 2.5 meters, yes, I know. If it's 2 kilometers, it's a different issue. So you can see that this is a vague this thing. Are you going to use it during rain as well as during sunshine? Then it's a different angle. So like that, gradually you get into this one and then arrive at how best this can be. We are not asking for a solution now. The questions, answer, and then define the problem. So finally at the end, say the user would like to have an electric connection which is workable in all weather conditions and concealed so that the traffic and other things will not be disturbed. Like that, a few things are to be taken and then he has to give it out. So this will be the way in which, here we are not going to ask for designing. It's only a question of defining the problem perfectly to see that they can proceed further with that one. Once you define the problem, only design starts. I think the need is the first one. Need is to be clarified by questioning. The idea of a designer is always to question the user or the client. And when you start questioning, then only you get the clues as to what the client or the user wants, and accordingly you can have the specification of the design worked out very clearly to the point, and that's called problem definition. So define the problem of this type. So at least some 5-6 questions he has to put in, and he has to answer the one, because let him think about that answer and then continue. I'm not saying that he puts a question only, but give an answer, and based on those answers he defines the problem. Another design problem, self-closing hinge. Self-closing means that after the door is open, it will close without pushing it back. That is, you open it. How can the hinge shown below be made self-closing? I mean, I'm not asking for self-closing methods. There are a number of other methods. You can have a closure, all the things are there, but we are not on the hinge. How can you put it up? You can give a clue. Gravity could help. That means when you open, it just goes a little high, and then when you it will slide back to that. So there will be a small projection at the interface of these two, the two. So it slightly go up. The design will be such that the top will be having a clearance of that type, the door, so that it can go by about 3 millimeter, 4 millimeter, and once it opens, because of the gravity, it will come back. So this is a simple design which can be thought of. So give a clue. Gravity helps in moving it back. Then you should be able to understand the gravity and the. So you can find out solutions of this type by giving minor clues, because if you do not give a clue, this fellow will not be easily solving this type, because he will think straight. The idea of a clue is to bring him back in that theme rather than confuse him out. Design for X. There are 4 chairs. What are the merits and demerits of the 4 designs? What are the first one? X, design for X. Storage, isn't it? So storage is the easiest storage is by folding it and keeping it out. So thereby it's a logistics. It's not very comfortable. You can't sit there more than 3 hours. The second one, yes, it has got little more comfort. It's also storageable, but it's more space consuming, because you can put it over and over. The third one, it's not comfortable nor the last one is very comfortable but impossible to store. If you have 10 of them, one room is lost. So you see how the designs can be evaluated from the angle of storage, transportation. Storage and transportation are combined. If you can put 100 of this one in a lorry and take this thing, whereas the other one only about 20. So like that, you can see that there are a number of difficulties coming out of it. The last one is a ceiling lamp. Design for X. What will be there? Yeah. Design says, space saving design, no doubt. Energy saving depends on the bulb which you put there. Yeah, you are looking only from the engineer's angle. That's why all these things are coming. We are talking about energy saving aesthetics there, right? Yeah, replacing the bulb is a tough thing. Yeah, and then it's not that safe as to happen, because something happens and then comes down, it's broken, because it's only just held by screws. So one is that safety is limited, because while doing it also it can fall, and replacing the bulb is a tough thing. So you can find out how best the answers can be brought in there. If he says aesthetics, yes, it is good, but if he says it illuminates very well, and you can put two of them and you can get better illumination. That's a different issue. Yeah. This is a little more tougher one. Tomatoes are coming in a conveyor and it's put in two, because they vibrate it so that they can gradually get into two tubes. At the end, what happens is that 3 and 3 are to be packed together. And not by hand, by some means. How will you do that? Those who know about it, in no time they will find out. But those who haven't thought about, see what happens, it's coming like this. There will be a piece like this. Then you open the 3 will come. Then this one will go, other one will go off. So what it does is, it just does like this. And both sides it will be doing like this. So 3 is taken, 3 is taken, 3 is out, 3 is out. That's a simple design. But then it requires thinking which is slightly different. I agree. It's not that simple as what you think. So that way you can have some questions. Understand that if I have something like this, if it's like this, if I move it like this, it will fall here. When I take it out, it comes. Only thing is there will be 3 pieces. The width will be, the sizes should be somewhat. Similar question can be asked, how will you size oranges? Oranges have to be sized, separated depending on the sizes. How will you do that? Apple or orange or egg cannot be done because it breaks. Sorting how way? Longer? Well, the big one will stop the rest of it. Where? But how do you ensure that the bigger one goes to the next channel? No, it's all mixed up, isn't it? Everything is mixed up. So it's coming in whatever fashion they come. So if the bigger one comes and blocks a narrower one, it stops the rest of it getting in there, isn't it? One method is to put 2 rolls like this, Yeah, like this. The small one will fall down, the larger one will go and then fall, and then you can separate it out. Very simple design. You keep it a little angle and slope out. So as it comes, the small one will fall. Of course, you give a size variation. Up to that one, it will get into the tube. The next one will get into the next one. 3, 4 like this. Other one is to put holes. One problem with the hole is that big one will stop. So you have to be careful, because what will happen? The large one, if you put it in the first, everything will go there. So you have to be careful in designing things with a hole, because blocking the hole is possible by larger ones. So this is a very easy design where the classification can be. So these are some of the type of questions we are thinking of giving. These are little longer ones, 20 minutes, half an hour roughly, so that you can give some clues can be given. You can say 3 at a time by means of a separation device. You can give it out. Then clever fellows will immediately identify how 3 means, okay, this one. Oh, if I remove it, it will stay there. If I remove it, it will go down. So that concept is to be brought out like this. Pencil design. Have you ever seen a square pencil or a triangular this thing? Why 6-sided? Ask why pencil is 6-sided. When you hold it, it's a hexagon which is coming here. 3 points are coming, and it will hold at the hexagonal point. You can have a round one because that will fit into this. but a triangle and a square will not fit into that configuration. So effectively a hexagon is a better design, and of course circular ones are also used normally. These are the only two options available there. Now rolling is the problem, is there? Yes, when you have got a drawing board it will roll down. But it's used and mostly the color pencils are normally round ones. So these are some of the examples which I gave, and then what I want all of you to think about good questions of the first category, namely short ones. If it is a little tough, give clues, not direct clues, indirect clues. The other two questions, plan it for a solution within about 10 to 15 minutes, but give 25 minutes, because all of them will not be that good in thinking and then bringing it out. And one will be a sketching problem, a simple sketch, which is seen normally, don't make a complex component because you will not be able to sketch it out. Simple component, simple part, which can be, how many of you know how the cycle bell works? The one which, yeah. But then you can give an exercise for the students to look in and sketch it out. It's a good exercise, a simple thing but working out very well. There's no need for anything else rather than just press it out. It just gives you the, or a calling bell, a simple press, you can sketch it out. And then only he will think, oh, there is a symbol which is inside. Otherwise he thinks that something else is happening there. So look into that. So ask them to be observing, and when you give some problems, thereafter he will start looking into it. I can guarantee that students are very clever. Once you give 3 questions of this type, next time onwards, whenever they see something, they will look in what is the peculiarity of this design. That's all what we want out of this one. So these will be the examples, general examples which I have mentioned, but none of us will, any question? But none of us will be involved in the question paper setting. You are the people who are going to set the question paper. I have just given only examples. So I have given only examples. Please think about the questions now itself. It takes time. It is not that simple. I'll give another. I don't know whether it. And when a tube like this, I will make 2 of them of the same size, same type. 2 of them are available. I want to make a frame for a chair. So what's the? Actually, it's slightly different. I'll put it like this. Not directly 90. Like I don't have a wire, however, it will be easier to show. Aluminium company don't have it. A bent tube or a wire, whatever might be. It's like I got 2 pieces of this one. Frame. I want to make a frame for a chair. Frame only, not seat and all. Of them. One is like this. Another one. No more. But you can imagine, already 2 legs are there. What you want is another 2 legs. So reverse it and put it there. It will be like this. Come like this, and the other one will come like this. So effectively it will come like this. turn like this, and then it comes down. So it becomes a tree. So the thinking is concealed there, but at the same time you can do that. So such questions are very interesting and intelligent questions. If you are able to get one or two of that one, it will be very good, because then the students will start thinking like that. The idea is that let them be good designers. In course of time, the jobs are not going to be given by Tata and others. They have to find their own jobs, or else they have to be creative. And that is happening in the whole country now, startups. So if they are clever in understanding things and the situations and the demand, they will start thinking, of course, this is mechanical designs, these are simple designs, but electronic designs, many things are similar. There is no difference. Thinking process is the same. So that way you will be able to do that one for many examples. So that's about the question paper. Any questions on that one? But I request all who are attending and taking classes, prepare the questions now itself, because it's not a one-day job or a one-hour job. It's almost a one-month job. If you think about a question, think and then clearly bring it so that a student can understand your question also. So clear things are there. Sketches are to be taken in such a way that you clearly mention what is to be observed in the design. Okay?
So we have questions from other colleges also.
Yeah,
so
please.
We are going to connect the bridge.
Any other questions?
So can I take this?
No, please. I'll take this. Any questions? How are the students getting interested in this one? There is a genuine interest, because these are the subjects which are more interesting than mathematics. And the first year should not be killed by that subject. See, the idea is that they excite the students for the first year. Then the interest should never be lost in the first year. We have been teaching things which were not required in the first year, but then the students think that the engineering is all this one and there is nothing called the challenges or anything. So bring in challenges, let them do the project, let them see how they can realize their dreams out of the engineering discipline, and that's all what we require. One thing is, a hammer, you can sketch a hammer with a nail puller. Those who have observed, they will sketch it, but those who have not observed, they will put something which is totally not a hammer.
Yes.
This is a message to all the participants from other clusters. Now you can join in the bridge which has been mailed to you across and start raising your questions. And whenever you are not asking any questions, please mute your phone, either by phone itself or by dialing the procedure which has been told. Thanks. Give us 2 minutes, we will be in the bridge, and whatever you speak from other colleges also will be audible over here.
That question can be answered, the leaves are to be collected. One is that, yes, the broom can be used, there's no doubt. Or can be used. But only thing is that electricity should be there. So there are conditions in which you can do. Then you can also have a sticker. So you give the options there and then select the right one which is better for the trial. You cannot use the electricity in the rainy season, you can't use the globe. There will be limitations. The rainy season, this will be the best. The product does not work on all conditions and all terrain. If he knows about that, that's good. Then he knows how to design. But give a design. If there are very good interested students, let him make the design. Let him make a prototype. In fact, you can encourage them because the project is for 1 or 2 months. So he will be able to make it out, and then little bit of money from the college can be used for that. Because we are only allowing them to and for this money is not a great thing for anyone to be spent.
Hello.
So encourage the
Sridhar, you are understandable, no problem. Just keep it on the line.
The other one,
Let the bridge be open. ഇതുവഴി വരണില്ല കേട്ടോ.
Likewise, here, a large number of projects can be done.
This is issue. We are through.
So,
വരണ വിളിക്കാൻ
encourage the students to think and then bring out good products. And it's something.
Hello, is it Srigas? Hello?
Because something is interesting.
Yeah. Just keep the bridge on and keep talking something. We are trying to explain it. Hello?
ഇതിന്റെ ലൗഡ് സ്പീക്കർ കട്ട് ചെയ്തിട്ട് കണക്ട് ചെയ്ത്
ഇത് കണക്ട് ചെയ്ത് ലൗഡ് സ്പീക്കർ ഓട്ടോമാറ്റിക്കായിട്ട് പോകും. അത്രേ ഉള്ളൂ. ഹലോ, ഒരു മിനിറ്റ്. Speak something, Sriraj. Hello. Varun വിളിക്കും. Possible. There is some connectivity issue here. I'm able to connect to the bridge here. Through my phone, I'm hearing. ഇതിന് കറക്റ്റ് സ്പീക്കറോ? Let me try the speaker. എല്ലാവർക്കും കേൾക്കില്ല. ഹലോ. ഹലോ.
Hello.
Speak something, Sriraj. Yeah. Ask some question on design. Maybe in IT, it's okay. It's our personal concerns.
So design needs hardware.
Hello.
A good software design also is having the same procedure.
Hello.
Hello. Yeah. That's okay. Thanks. Yeah. Is there any question from any of the colleges? Please identify the college and raise the question.
Hello.
Yeah. Yeah. So it's all very clear.
Can you hear me?
Yeah, we can hear you.
Sir, I am Amal. I'm calling from engg. So, my question is that, I mentioned that the mark will be, less mark will be given for crazy ideas. But how can we say an idea is a crazy one? Because before the invention of flying was a crazy idea.
Yeah.
Hello?
Yeah. It's very difficult to identify a crazy idea because many of the crazy ideas are workable ideas in course of time. So only from the